difficulty as well. So this is the slides I will present about the OCDMA for next generation system. As you know, nowadays in the wireless communication system, there is a huge development. You can see there is first G, second G, third G, 4G, and so on. And now they are working on 5G on a practical side of a view. So there are a limitation in wireless communication system, as you know, because of the huge frequency banded uses. Each frequencies they occupy a specific band. So as the results, they will lead to the overlapping or interference and such as these things. So today's talk will be about the optical communication system, which means optical code division multiple access system, which is called OCDMA. Either we write OCDMA or optical code division multiple access system. So branch is different from wireless. It is totally based on optical communication system. So OCDMA is a huge topic, so I cannot cover within 1 hour. So I would go directly to the interesting points, which is they called Li-Fi. One of the application of OCDMA is they called Li-Fi. I think you know what is Wi-Fi. Have you heard about Wi-Fi?
Yes, yes, doctor.
So now all the companies and the researchers they are trying to shift from Wi-Fi to Li-Fi. So what is Li-Fi? Basically, Li-Fi is a transmission of delta data or video or image through a light source. Instead of using wireless communication system frequency, now we're using a light. As shown, as you can see here on the slide, we use a light we call LED light, but this is not normal LED light. It's a light with a specific wavelength, with specific power that we can carry the information inside the light. Now, as you know, the light is faster than the frequency. Why? Anyone can give idea why the light has faster than the human eyes or even the wireless communications? Because the speed of the light can reach up to 3 10 to power 8. So can the download information in this case will be higher than the wireless or the wire or any other device. So this was the introduction about Li-Fi. Li-Fi means light fidelity. Look like the Wi-Fi. I think everybody know Wi-Fi. Wi-Fi is wireless fidelity. Here we use light fidelity. So it is a part of VLC, which is visible light communication technology, which has been developed by this team. The Li-Fi is a part of VLC, which is follow the standard IEEE 80215. And also they plan to use LED light bulbs. So these devices are usually they use light of LED light emitting source instead of using the frequency. So the Li-Fi has the advantages in terms of cheaper than wireless communication, which is the optical version of the Wi-Fi. And also in terms of speed, you can see the speed of the light is faster than the speed of wireless communication system. That's why it will be instead of radio wave in the future. So in the future now, all the companies, they are trying to shift from wireless because of the huge limitation of wireless in terms of noise, bandwidth, attenuation. They try to use this one they call light fidelity. So the topics is the called very hot topics now in the world, and many researchers in Germany, Australia, even in Middle East, they start to do research about why we don't use the light instead of frequency. Okay, we have many advantages in this technology. So the important about Li-Fi, now how we can change Wi-Fi to Li-Fi. And number two, this technology use a part of electromagnetic. So here we will use light, means we will use electromagnetic waves, means we use all the spectrum of the visible spectrum. So Li-Fi, it has been already achieved high speed in the lab. Now I think they already reached to 100 gigabit per second. One research team in German, they already achieved to transmit 100 gigabit per second. You can see the amount gigabit per second, which is impossible to achieve in wireless or even in the wire line. Or sometimes 500 megabits, which is theoretically can be used by LED. So rather than capable only 100 megabit per second in wireless. So here are the major issues. The issues regarding the radio spectrum nowadays, they deal either with capacity or the efficiency or the availability or the security. These, any companies like Omantel, Orido, or Vodafone, they are focusing on these four categories, either security, availability, efficiency, and capacity. So which of these factors is important to the communication company? Of course, it depending on the user, depending on the data rate, on the amount, and how much the user can pay to offer all these services. So if you refer to capacity, you can see the wire or the radio waves. It has cost. In terms of capacity, these are the main factors. Either the radio waves, the cost, and expensive, and the bandwidth compared with other spectrum, and the efficiency of the spectrum for increasing the data. So the capacity involved whether we use radio frequency, how much the cost, whether it is costly or expensive, and the bandwidth associated with this, and this the increasing data rate. The efficiency we can how much power station or base station we need to install in order to achieve transmitting of radio wave and also to cool the radio station cabinet. If you install a power station we call BSS or PTS, we need to cool this station, and also we need to we need to build up many towers in order to cover. So this we call the efficiency. Usually achieved is 5% the efficiency of the wireless. So the availability, whether this available for range of base stations or limited availability on available in the aircraft. So what is the availability of this service? For example, in the airplane or aircraft, it is very difficult to achieve the connection in the internet because the flight has a distance up to the earth. So the covering area or the covering will be very limited, cannot reach to the aircraft level. Also, the security is the most issue. The security nowadays, how to achieve that our information is received by the end party will be correct without any error or without any mistakes. So the securities means the second party or the second user or the end user received the information securely without any spy or any installing of information on it. So this can be solved by using a spread spectrum. As you know, the electromagnetic spectrum is divided into four spectrums: radio wave, infrared, visible, ultraviolet, X-rays, and gamma rays. So here you can see our frequencies now we are using in Wi-Fi, wireless, 2G, 5G is around here, which is in megahertz, which tend to power megahertz. If you go to gigahertz, which is ultraviolet, we will use the light. So this is the light. Here also the advantages. Here we don't need we don't need license to open the light to obtain the spectrum here, because we used ultraviolet. Whereas here if we want to use a spectrum, if I want to establish a company, telecommunication company, so I have to go to ITU. ITU means International Telecommunication Company Union. This one, I have to pay money in order to get spectrum. So this amount of money is almost free in the light, in the free space, or they call light spectrum, because nobody use these spectrum, which is visible, and ultraviolet is almost free of charge and also open. So here, this is the coding, where that's what I mentioned, the code division multiplexing. We transmit a light in such a code 110111. When I have one, means there is light source, means on. When there is off, means there is no light, which is off. So signaling data stream can reach up to 220 megabit per second and no for video, usable for video streams. So the Li-Fi, it means that all the bit streams which have been transmitted from TX to RX will be received as a binary streams instead of sending it like analog signal or like uh, uh, cosine omega t or sine omega t like analog signal. All signal will be sent as a digital 10101. So here the working of Li-Fi is first is developed by Prof. Haas, which is a famous talk in the TED talks. Then he explained the very simple why LED is on and why we have to transmit on, why to transmit off based on this code sequence. Then further he enhanced can made in this method like using array of LED for using parallel data. If using more than one LED means we can transmit more than one data in as a parallel form instead of using one data one light source. So here you can see that using a mixture of green, red, or blue light, all the different frequencies or different light wavelengths can be changed. So instead of using frequencies, we will use wavelengths. So these wavelengths will be presenting either red or green or blue light for different data channel. So can here see this is normal light. Our light, the expected light will be like this one. So this light will be specific wavelengths and specific power and a specific bandwidth. So here will be also the detector, because when transmit a light, we need a photo detector in order to convert the light wave into a binary sequence, or we need an image sensor, also same meaning, to detect the light or to convert the light from light to digit. So the working principle you can see here, this is the internet, this is the receiver, this is the binary, this is where lid. So the information will be integrated over the light source will be carrying inside the binary sequence. Then we send the sequence as a light. So the light will be detected at the photo detector. So the photo detector will receive the light. Then this light will be converted into a binary digit 10101. So here can be processed. The conversion will be changed in the light amplitude will be changing into a binary, so the intensity of the power will be converted into light. So that depending on the intensity here, there is a decision device that compare if there is a light will be a binary one. If there is a no light or almost low power, so it will be 0. So this the receiving or the amplification we need here to increase the power if the power is low. So at the end, instead of using frequencies or wave, we will send a light. So this the data will be carried inside the light. So here is the explanation, which is the how we transmit for the visible ultraviolet. So we can, as the speed of the internet increase high, you can also download high increase games, music, and so on in a few seconds rather than in minutes. Also, this technology limitation have been put on the uses of Wi-Fi, means you no more need to ignore that Wi-Fi enabled to access systems. Finally, you can simply stand using light and suffer the interference which can be associated with the wireless. Here the interference will be less. So there cannot be anything better than this technology, because all the benefit here we can achieve high speed, interference will be reduced, noise will be reduced, and there's a security also will be high. We cannot spy on these unless you have to develop a new system. So if you make a comparison between wireless and here the current wireless and this one the future wireless, you can see the current now they use IEEE 8011N. I think everybody knows these features. So here we can 15 megabit per second or Bluetooth 3 megabit per second. And here in the future, they called wireless giga internet, they can reach 2 gigabit second and 1 gigabit per second. This all the wireless technology. Now the advantages of using this technology, the bandwidth will be 10,000 10 times than the radio bandwidth, will be high efficiency and more availability and high security. The disadvantage here, the presence of light is essential. Means we have to establish an infrastructure that can provide a light for the transmitting and for the collecting. And there will be the interference from the sunlight. Here also, if we during the daylight, it might be sometimes will be interfering from the sunlight during morning or evening. And we need special LED, not this normal LED using of the system. Any question to know about this technology?
Keep the questions to the end of the presentation, Doc.
Okay. No, I just want to see the interaction of the students. So now we go application. If you see now, I think in like Sahab University or Sahab offices or any company of offices, and instead of using wireless or wire, now our all offices, including the dean, the program chairperson, the lecturer, they use the wire. Now the new technology here, they say that we changing the wire internet, we use the light spot, and this light spot here they have infrastructure inside. It means they have transmitter, modulator, channel, data bit, photo detector, all inside. So here we will transmit information via a light instead of wireless. Instead of switching wireless Wi-Fi, of course this one also have to change the mobile user. It means the mobile companies also they have to switch or they have to insert, develop a new button here they call Wi-Fi in order to detect the Wi-Fi. So this picture in the future, what is going in the future, maybe after 10 years. After 10 years, all the communication that will be through the light because of these advantages. So you can see the printer will be connected to internet via the light, the mobile will be connected, the phone calls, the printer, the switching and off, which is they called Internet of Things. I think everybody hears about Internet of Things. Everything will be connected on the internet, so the internet will be predict the future. If you have a meeting or it will be raining next hours, or if you have a flight or you have the meeting, this they called Internet of Things. Even now they start to study to insert this technology in the aircraft. I think everybody uh, has been in the aircraft, and here they have a light bulbs. They have studied that why we don't change this normal light bulb for reading. We be into for transmitting light, I mean Li-Fi. They change this light bulb and insert a Li-Fi instead of it, so we can each user will be connected to internet, which is impossible nowadays to connect to the internet using Wi-Fi, because possible to get Wi-Fi in the airplane. So this is the most reliable technology that we can get the internet in the flight 24 hours on all of the flight. Also, the problem of Wi-Fi here, I think everybody, when you landing or land off or land in, the the pilot asks the passenger to switch off your mobile phone. Why are they asking to ask to switch off the mobile phone? To avoid interference in the wireless. But here there will be no interference at all because we are dealing with light. Another application they use in the RF on the and radio frequencies, and the big companies like oil companies and nuclear, all these which is called very dangerous technologies. This they give a secure and safe technology. They use also in the traffic lighting. So each car will be communicating with other car by using LED. So if have a distance or have want to go a different direction or straight direction, so can send message to this signals, and this car can send message that this car they have a problem, or they want to turn right or left and so on. And can we add also here, they instead of the light, I think everybody has in the street there is light. They want to install the Li-Fi in the light, so it will be a smart city. So one of the way to convert a normal city to a smart city is installing the Li-Fi technology in the street, so everybody can get internet inside this light. So the conclusion, we can see that a high-speed 10 gigabit can be achieved, and all the limitation of the radio spectrum can be overcome and can be removed in terms of security, noise, bandwidth efficiency, and so on. And Li-Fi can solve for essential problem of wireless nowadays, which is the interference, the noise, even the cost, because if the cost of the internet is high. So here in the Li-Fi, if we establish, you will get a cost-effective system and reliable receiving of data 1010 as a code division multiple access systems. So this is the end of my presentation, and I hope you can benefit from this technology and this new innovation in the future. Hopefully will be in the Oman and in the Soha University.
Thank you.
So if you have
Thank
any
you.
question or any discussion.
Thank you,
Yes.
Dr. Hilal. Yeah, I may start the questions by asking about the light. It's coming through LED, and there is a source.
Yes.
Does it mean that the national network, the national grid, the utility, will be used? I mean, the signals, the internet things sent by the as the signals through the wires to the source, and then it's converted to the light through the LED. Is this? I mean, did I understand it in this way correct or not?
Yeah, yeah.
I mean,
This
okay.
technology they use now, they called FSO, free space
Yes,
optics.
I see.
So free space optics, they use only outdoor. Li-Fi they use indoor and outdoor. That's why the infrastructure, but this one you have to change all the infrastructure of the telephone, the infrastructure of the building. So it is a new revolutions of everything. So everything have to change, and they have to start from the infrastructure, how to make the building, the light, in order to transmit the data from, as you mentioned, from TX, which means the transmitter, then pass through the channel, which is the free space here channel, then to the receiver. So the receiver, you have to choose which one you want to use: PIN photodiode, APD photodiode, avalanche photodiode. Even they go to nanotechnology, they develop specific photodiode in order to detect even low power of light. So all these things have been to discuss and to develop one by one. But now they have FSO. The FSO they use in, I think, in between ministries they use free space optics, which they call VLC technology.
Okay. IEEE members, if you have any question, please you can ask Dr. Hilal, even in Arabic, English. He can answer Arabic and English. Ladies, gentlemen.
Thank you, doctor. Everything is clear. Thank you.
Okay,
Okay.
at the end of this webinar and this workshop, I would like to thank, in the name of IEEE Sohar branch and the students organized this workshop, Dr. Hilal for valuable discussion and time for the intensive explanation of this new and hot topic, Li-Fi. And we look forward for more activities and more from IEEE branch. Thank you, Dr. Hilal, for your time.
Inshallah. You are most welcome and thank for all the audience and hope all you benefit from this talk.
Thank you very much. I will end